Let me introduce our next speaker, Mary Lou Maher. Mary Lou is the director of the Computing Community Consortium at the Computing Research Association, or CRA. In this role, she directs and manages computing research visioning activities, evaluation, and communication through the participation of the CCC Council and broader computing research community. She gained her research experience as a professor at Carnegie Mellon University, the University of Sydney, the University of Maryland, and the University of North Carolina, Charlotte. She served as a program director at NSF in the Division of Information and Intelligence Systems. Her research areas include artificial intelligence, human-centered computing, HCI, CS education, and AI literacy. She is an author of over 300 publications and has an H-index of 62 with over 14,000 citations. So without further delay, please join me in welcoming Mary Lou.
Hello. Thank you so much for coming. I want to start by saying, as a researcher, having the opportunity to talk about the Computing Community Consortium is a real pleasure. I have my own research career. I started here at CRA in February. And what I've learned since February is that this is a national gem. CRA, and specifically the Computing Community Consortium, provides opportunities for you, for researchers, to have your voice heard, to have support for visioning activity, and to get that visioning out there. And so I'll give you just a little bit of history to put this all into context. The CRA started in the 70s as the Computer Science Board. As it increased in size and in scope, it redefined itself to be the Computing Research Association. I'll talk a little bit about what it is now. CCC started in, I think, around 2006 with a cooperative agreement funded by NSF, and it provided the opportunity for the research community specifically to have a voice. It provided an opportunity to catalyze that voice and make sure it's heard. And so really, CCC is you. It's about you and it's for you. It's funded by NSF, but maintains an independence from NSF in providing the voice for the community. We work very closely with NSF, but we're funded for you. Before I go into any of the details of what we're doing with visioning, I want to thank our council. You may see yourself here. There are people on the council who are here today. And if you don't see yourself here, maybe you will one day. It is an opportunity for you to get involved. Or maybe you will work with this council to do a visioning activity that you're interested in. Or maybe you'll be called upon to reply to a request for information from a federal agency. The council is led by Nadia Bliss at Arizona State. The vice chair is Katie Seek. Dan Lepresti, he was the outgoing chair, and they provide the leadership along with the executive committee for what CCC does today. It's a 3-year appointment, and you roll, about a third of it rolls off every year. So the mission of the CRA, I'm going to step back a little bit because I think CCC is best understood in the context of CRA. So the mission of CRA is to catalyze computing research by joining with industry, government, and academia. While I showed that the CCC is primarily made up of people from universities, we do work with government agencies and we do work with industry. And basically the idea is to lead the community, to provide that opportunity for you, to provide leadership for this country. So CRA has a membership which partially funds its activities with 300 institutions across industry, government, and academia. If your institution is a member of CRA, you may be receiving the CRA news, you may be receiving the CRA downloads. You'll see opportunities to engage and participate. Many of the activities that you engage in are funded by CRA. CRA also has industry, lab, and center members, as you see here. And we're always reaching out. So if you aren't yet a member, please reach out to us. It's a great opportunity, not only for you to support something very special in this country, but also to participate and provide leadership. CRA has 6 programmatic committees. This will give you the context for CCC. CRAE is about education. CERP provides research evaluation for your research projects. WP is about widening participation. CRAI is our industry council. And the CRA Government Affairs, we have a Government Affairs Committee that actually looks after the relationship that CRA and computing research has with federal agencies, congressional staffers, and other people on the Hill. So if you join CRA, you may just want to read the blog about what's happening in government, which will be really interesting as we transition into a new government, so you can actually be informed and involved. CCC is one of them. I left that for last because the rest of my talk will be about what CCC does. Our mission is to envision and enable the pursuit of computing research that aligns with national and global challenges. And what we do to achieve that is we engage with the community like you through a wide range of mechanisms. We communicate effectively. So communication is a really important part of what CCC does. We communicate with the community, we communicate with federal agencies, we communicate with national labs, we communicate with the public. And we organize a strategic mix of in-person and virtual community activities to prompt discussions, capture forward-looking ideas, and formulate action plans. Ideally, we produce compelling research visions that are designed for maximal impact. So what does that all mean? I mean, you have to then take that and operationalize it. And so here's how it's operationalized. Our workshops are our flagship. I don't know if you've participated in any of our workshops, but if you have, you'll realize those are workshops that are about visioning, and I'll talk more about visioning in a minute, but it's not like a conference workshop where you talk about recent advances and developments. You have people give talks about their research. In our workshops, we set priorities. We identify research challenges. We provide the basis for many solicitations at NSF. You are the voice to inform NSF about what's important, what's coming up, what needs attention. We do this through agency requests. We do respond to requests for information from federal agencies where we will reach out to you and ask you to get involved, participate in discussions, and then we write up the response. We have open visioning calls for the community to propose a visioning workshop, and we have council-led workshops and visioning activities that support reports, white papers, roadmaps, and we have a leadership program to mentor academics on how to take on leadership positions, leadership roles, either in service to the government or in service to the research community. We speak to the public. We have a blog and a LinkedIn page. We speak to funding agencies, and we speak to science policy leadership. So we give your voice a platform. The sort of things we do, the outcomes, the communication products, as you might call it. We have social media, LinkedIn, podcasts and video channels on YouTube. We have a blog post that goes out regularly. We write workshop reports. And when I say we write, You write the content, but we do the actual writing and make sure it gets out there. We give presentations like this, and we do quad papers. Let me talk about quad papers for a few minutes. Every 4 years, there's a change in the administration, federal administration. And every 4 years, the community comes together to identify pressing issues that the transition team should be aware of in computing research. And they're packaged as quad papers, which are only about 2 or 3 pages, very high level, identifying the challenges that computing research faces that is of national interest. We've just completed a round of quad papers, and we're in that stage now to identify people in the transition teams and congressional staffers and NSF program directors that might be interested in each of those different challenges. I'm going to introduce our visioning process, give you some examples, and invite you to participate. So our visioning process has 3 stages. One is called nucleation, and that is where someone approaches us and says, I have an idea for visioning. And then we work with them. The council works with them, the staff works with them to build that out and to identify how it meets our definition of visioning. Then there's a crystallization period where we run a series of workshops, some roundtable discussions, we invite community participants, we bring in experts, we bring in people from federal agencies, national labs, and we work with you to develop that vision into a report, and then we go to the broadening stage. So it doesn't stop when the workshop ends. From my experience, when a workshop ends at a conference, even with the best of intentions, not much happens afterward. But we take this part as absolutely the most critical part for making impact, and that is to get it out there. We write the report with you, we produce it in different formats, we get it out through various communication channels, we take it to policymakers, we take it to funding agencies, we get it out on LinkedIn, we do everything we can to get your voice out there. Some examples of things that we've done recently, the 20-year community roadmap for AI isn't that recent, but I wanted to point it out here because it was extremely influential. This was published in 2019. It's arguably the basis for the AI Institute's program at NSF. There were a number of recommendations in there that were followed and that actually played out. It sort of predicted what was going to happen next, and it did. Now we're at the stage where we're very interested in finding community around revisiting this roadmap. What's next? If this was so influential, maybe it's time to sit back and look at it again and project again. Other examples of our visioning activities: we have community-driven approaches to research in technology and society. This is where we were focusing on the challenges that computing research faces in engaging the community in the research that it does. Sometimes we engage them in ways that is meaningful for us and not meaningful for them. Another activity we did was the 5-year update to the next steps in quantum computing. That's still out there, and we're sort of watching it play out in a way that the roadmap for AI played out. We've looked at the emerging bazaar of accelerators. What's happening with systems and applications? How can software possibly keep up as we continue to have all these accelerators come out? The future of pandemic prevention and response, that one obviously was extremely important, looking at how we responded to the last one and understanding how we can do that better. The last one that's on here, and this is not all of them, we have many, many workshop reports out there. I wanted to give you a sample to show you the breadth, but the future of research on social technologies, that one we're still pushing out. It's a very recent one that we developed. One of the ideas that came up there is, can we develop a computational measure of the health of a social technology platform. If we could do that, could we then have that measure as a goal to stay healthy and to identify paths to making sure social media, social technologies are good for the country? I'm going to take a few minutes to do a deep dive into a workshop that just happened in July. This is a workshop labeled The Future of Information Retrieval in the Age of Generative AI. What we've noticed is that people now, general public people, choose to go and search for information on ChatGPT instead of doing a Google search or web search. What that means is information retrieval now comes in two forms. You can do a web search, or you can do ChatGPT search. The preference for ChatGPT is because it's very friendly and conversational, it summarizes it, but there are issues there too with hallucinations, no sources, and so the information retrieval research community took this summer to step back and think about what does that mean for IR research. First of all, LLMs are changing the way people search for information. It's not just a different platform, it's changing us. IR technologies have substantial impact on generative AI applications in terms of their efficiency, effectiveness, robustness. And so we brought together a group of experts. The organizing committee was James Allen from UMass Amherst, Yunso Choi at NYU, and Hamed Samani. So this group came to us and said, we think this is important. Dan Lopresti joined the organizing committee, and then we had 3 staff. What do? We make sure the meetings happen, we take notes, we get the invitations out, we support the travel, we support all expenses while at the workshop, we take care of the venue, we listen to you, we write the notes, we produce the report. So it's a huge, lift of the voices of the people in the research community. What did they come up with? Well, the report is quite long. We encourage that the reports be comprehensive. They're not 1 or 2 pages like a quad paper. They're more like 40 pages. I've just sampled a few of the recommendations that are in the report to give you a sense of what does this look like. It isn't a research proposal, and it isn't doing the research itself. It's brainstorming about what should be done next. What would you do with a report like this? You might take it to your research lab at your university in the area of information retrieval or AI. We take it to NSF. We take it to policymakers. We go to the national academies and give a talk. We have a relationship with the Engineering Research Visioning Alliance. We show it to them. Some of the recommendations, the idea that maybe we need new algorithms. We need information access models that require reasoning. We can improve the training efficiency for large language models through information retrieval data curation. New user models. There's the idea of digital twins, which we've heard a few times today already, but this idea of a digital twin of us. As we are using information retrieval systems, recommender systems, search engines, databases, ChatGPT, it's possible now to have a digital twin of us. What does that even mean, and what role should that play? How does that introduce issues of privacy and security? And then new learning goals. Learn when to retrieve, when to generate. Develop personalized question answering systems. So this is just a sample, but it gives you an idea of what happens when you do visioning rather than do the research. I'm going to talk about our task force on grand challenges, because this is another area where we want to mobilize the computing research community to think bigger. You're thinking within your own research area and in your own research labs, but what are grand challenges for computing? Grand challenges are an amazing opportunity to bring a large group of interdisciplinary researchers together to do something important for the public, for society. And so we got together, this started about a year ago. We've had a few rounds of activities, open community feedback through our blog and our LinkedIn page. We've run virtual roundtables. We ran a session at the Snowbird conference, the CRA conference in July. We're working on a white paper and possibly running a workshop in the next year. So I want to motivate this a little bit. In 2013, the White House under Obama introduced the idea of generating 21st century grand challenges. And the quote here is really great for sort of setting the stage. Grand challenges are ambitious, but achievable. They harness science, technology, and innovation, and they solve important national or global problems that have the potential to capture the public's imagination. There's some examples here that the NSF, NIH, and DARPA came up with, the BRAIN Initiative. There's the USAID Grand Challenges for Development that was, I guess, including one specific one, saving lives at birth, catalyzes groundbreaking prevention and treatment, approaches for pregnant women and newborns in poor and low resource areas. The DOE, Sunshot. Sunshot was to make solar energy cost competitive with the cost of coal. And EV Everywhere, to make electric vehicles affordable as affordable as the gasoline powered. Now, this was in 2013. These grand challenges motivated funding agencies, they motivated researchers, they got behind them. What's that mean for computing? So this task force asked itself, what makes a challenge grand? We have a lot of research challenges, but what makes it grand? And then what is a computing research challenge versus a challenge that requires computing? That distinction is important because as we see many of the grand challenges being presented at the federal level, they are grand challenges that require computing. But what does it mean for it to be a computing grand challenge? There are two bullet items here, and I'll elaborate on it in the next slide, but one is that computing is about modeling and simulating the natural and human-made world, and that computing challenges integrate people and society with machines. It's not a standalone machine. And then finally, how do you know if you've solved it? So going on to grand challenges for computing, we've been reflecting what is it about computing that makes it special? How does it change us? And that a computing challenge is about tools. And some people might think, well, tools are fairly pedestrian, but if you think about tools, I mean, the simplest one is the hammer and the nail. If you have a hammer, everything looks like a nail. We've heard that so many times. And the apocryphal quotation from Archimedes, give me a lever long enough and a fulcrum on which to place it, and I shall move the world. And that's what computing does. It changes us. It changes the world. How does it do that? A computing tool actually provides a lens or a perspective on a problem by framing the problem. When we saw the presentation this morning about NASA, and we saw those visualizations of a black hole or visualizations of the sun and the way the sun energy spreads around the planets, these tools provide a perspective. So a computing tool gives a lens or a perspective to solve a problem. A new tool reframes the problem. ChatGPT has changed the way people search for information. When we come up with a new tool, it changes the world. And so this idea of a grand challenge for computing is for us to reflect on and us to project. How do we want to change the world? This is an example of a challenge that was placed in March 2006. And I want to point it out because it was a challenge that changed things, but it's not done yet. It didn't achieve what's stated here. This is Deborah Estrin. She said by 2020, researchers using visualization tools like Google Earth will be able to zoom in, not just on an old satellite image, but on multiple in situ observations of the Earth in real time. This was an era where people were beginning to reflect on, how do we get computing off the desk? How does computing move out into the world? And what does that look like? And as it moves out into the world, how do we do that responsibly and to better society? So this is an example of a grand challenge that was placed a decade ago, 2 decades, 2006, 2 decades. And so what we're looking for now at CCC is to help the community identify these grand challenges in computing, to work with you. And we've come up with this sort of a template. What is the challenge? Why is it barely feasible? What makes it grand? And then how will we know if we succeeded? And what we did with this is we went out to a session at Snowbird where we had a few hundred people in the room. We presented our ideas about what is a grand challenge. We gave them templates. They worked in groups, and they came up with some grand challenges, and we asked them to fill out the template. Some ideas from the roundtables and also from Snowbird. Here's just a list of them. Multilingual accessible AI, real-time translation, computer systems for personalized healthcare, net zero computing, cybersecurity and sustainability and edge computing. Are these grand challenges in computing? Are they going to mobilize communities? Are they measurable? And so we went through and had them fill it out. We looked at them. I'm going to show you a few of these just to give you a sense that if you want to do this, if you want to run a Grand Challenges session at a conference in your research lab, as part of the CCC, that's what our goal is, that more people elevate their thinking to the Grand Challenge level, and we help you do that by providing that support. So, transform computing by finding the best balance between resource use, environmental impact, and societal benefits. As we described these further, we made them better. We described them better, we identified measurable goals, we identified the impact on society. Data-driven healthcare. Transform how doctors deliver healthcare by considering personal data in the context of data collected for all individuals. Obviously, there's some problems there with privacy and security. Why is it barely feasible? What are the technologies that give us a starting point, but they don't give us the challenge solution? How will we know if we succeeded? Ubiquitous information provenance. Facilitate reliable, accurate, ubiquitous tracing of sources. I want to do this one twice. First, this is what we got back from the group that talked about align AI with human values. What's the challenge? To be able to assess decision outputs of an AI system with respect to their equivalence with human-only decision-making. Why is this barely feasible? Well, we don't really understand how humans work, let alone AI, and not all human values are equivalent. If we don't get alignment correct, AI alignment, then we have this disconnect between humans and AI. How will we know if we succeeded? So then we would engage in a critical discussion, and this is the example of the AI with human values. What does this even mean? It doesn't indicate in why this is barely feasible how any of it can be done. And finally, it's not realistically measurable as stated. And is this what we really want? Human decision makers, let's think about that. Ethically equivalent to human decision makers. Which human decision makers? Not all humans make ethical decisions. So how do we know which humans we should model it after? So rather than say we're going to put together the grand challenges in computing, what CCC wants to do is put together the guiding principles. And this is where we are working towards providing the support for you, the community, to identify grand challenges in computing. Impactful. Does it address a critical societal problem? And I don't mean in the sense of it's a problem that requires computing. Does the computing tool itself address a critical societal problem? Ambitious. Is the challenge tackling a problem of substantial complexity? Is it barely feasible? Are there major technical obstacles to be overcome? Is it interdisciplinary? Does it require multiple stakeholders, multiple fields of study, diverse backgrounds in order to solve it? That's the grand part. And measurable. We struggled over this one because if you can identify the metric, you may be setting your sights too low. But maybe you can identify indicators of success, and then that metric evolves over time. I'm going to finish up on this slide with a call to action. So CCC is there for the research computing community. You saw our council members. There's a lot of opportunities to get involved, to start to think how what you're doing, your lab, your company, can actually get involved in this visioning. One is propose a visioning activity. We have an open call all the time for proposals. And when we say proposals, these aren't proposals for research funding like NSF has. These are proposals for a visioning activity that we support. We will help you figure it out. We don't expect the proposals to come in fully formed and we say accepted or declined. We actually work with you. We workshop the proposal itself to make sure it addresses what we would call visioning activity rather than a workshop where people talk about their research. Or maybe you don't want to propose one, but you want to participate in one. We announce all of the workshops that we're running in advance with an open call for people who want to get involved. We're running one on citizen science. In the spring, we're running one on neural interfaces in the spring. Get involved and participate in one. Another way to get involved, and there are people in the room if you want to talk to them, nominate yourself to serve on the council. Our nominations call opens now. You start July 1st. Nominate yourself. We're looking for people like you. And then finally, define some grand challenges in computing. Computing grand challenges at your conferences you go to, inside your institution, right in your research lab. Ask us for the white paper. Send me email. We'll send you the white paper. Elevate the thinking of the research community to the level of grand challenges. Thank you for listening.
Michaela Taufer and Tennessee Knoxville. Thank you, Mary Lou, for this vision and sharing that with us. And indeed, you remind us that research is not reactive, but is proactive. We need to brainstorm. We need to understand the direction. And when we look at the direction, something that comes to my mind is that, are we including the early career? Are we including the next generation of scientists, researchers, engineers? I feel sometimes that we let them out in this important brainstorming, and they have so much energy and creativity. What can we do to include them, and what could CCC do?
Thank you. That's really important, and it's one thing that I should have mentioned. When we work with a proposal for a workshop, we work very hard to diversify the participation in the workshop itself. While our proposals tend to come from more senior people, our workshops include early career researchers. We try and get diversity in terms of geographical location. We get international diversity. We get academia and industry. But I appreciate your point. How do we get the early career researchers to think like this? So one of the things that we're doing in February, we also at CRA have a CI Fellows program, and that is an NSF award to fund fellowships in computing research. There's 120 fellows that we funded. And in February, we're going to have a symposium to celebrate all the amazing things they've done. One of the sessions we're running at that symposium is a Grand Challenges session to help them think about how do you think bigger than your PhD? How do you, over the course of your career, think about societal impact? Think about interdisciplinary research. So we're trying. It's very hard because most early career researchers don't really have the time to do the service kind of activities that the council does, but yet they should have a voice in the visioning that we do.
Thank you.
Thank you, Mary, for a very inspiring talk. I really like this concept of grand challenges in computing. Actually, I can't think of a single societal grand challenge that doesn't involve a grand challenge in computing.
Yeah.
Right? And that's driving so much research in computer science. However, we don't have a systematic way for translating this research so that it can have the impact it is. Like, for example, like medicine, where translational medicine is part of the research process. What do you think about, what are your thoughts on having such a systematic process for computing research?
You know, I think it's a different kind of thinking that's needed to do the research, to achieve the challenge, and to do the translation, the propagation, the integration into where that new tool can make its most impact. And so in the early stages of identifying a grand challenge, that's part of the discussion. How do you ensure it gets out there? I think if we held more grand challenges sessions that followed these guiding principles, we would have more success rate. We see that NSF is also engaged in this with the TIP program. It's not just about doing your research, writing your papers, and going home. I had a large grant from NSF before I started at CRA, where they had an emphasis on not just dissemination, but propagation. How do you package this? Not how do you write about it? How do you package it for adoption? Researchers rarely think about that, but it's important to do. It means that more of the amazing research that our researchers do actually makes a difference and has that impact. And I don't mean just writing a paragraph about broader impact. I mean packaging so that it can be adopted. But I think that's where the Grand Challenges also elevates the conversation. Thank you.
Well, join me in thanking Mary Lou again for a brilliant talk, and a big round of applause to both our speakers. Thank you very much. Well, I hope you enjoy the rest of the conference and the other sessions, and thank you for attending this invited talk session.